This video is the part 2 to the similar figures video, and I am going to start with example 3 because that's where we left off. So I'm going to a new page for this one. All right, so I was mentioning that we're going to use information that you learned from 8th grade math to determine if the triangles are similar. So for example 3, I need just a minute to sketch this out. So pause for just a second here, and I'm going to try my best, but just bear with me here. Yikes. Oh my goodness, I don't think I did a very good job on that at all, but we'll just pretend. All right, so I'm going to call this A, B, C, and then we'll call this D and E. And then I'm going to tell you that this is, and it looks nothing like it, so just pretend. We're going to say that this is 60 degrees, and this is 120 degrees. And what I want to know is if the large triangle, if that triangle is similar to that triangle, okay? So again, we're looking to see if the triangle, this big triangle here, is similar to this little triangle. All right, so obviously we're looking at the angles because we didn't give you any side measurements. So what I want to do is think about what I know from previous math to fill in some other angles on this triangle. So let's see, I know that this right here, if you look at this, these are parallel lines with a transversal. So we're going to use things like alternate interior, alternate exterior, corresponding, linear pair, supplementary, that kind of thing. So I know that if this angle right here is 120 degrees, I know I can figure out this angle right here. I also know that this angle is corresponding to this angle. But in the end, I know that this angle right here is 60 degrees. All right. Next up, I know that angle A appears in both triangles because angle A is the top of that triangle and angle A is the top of the big triangle. So I know that even though I don't know what this measurement is, I know that angle A is going to be congruent to itself. So I don't think you need to do this, but I'm just going to do it since this is an instructional video. If we were to separate these two triangles, we have triangle, this little one here, which is ADE, and I know that mark is there, and this is 60 degrees. And then we have the bigger triangle, and again, just, oh my gosh, that was pathetic. But we'll just play along. It's a video, so I really don't want to start over. I might not be able to draw any better. All right, but then we have the bigger triangle, which is triangle ABC. That one has that mark up here, and this angle down here is 60 degrees. So here's what I know. I know that those two angles are going to be congruent. I know that those two angles are going to be congruent. And I know, even though I can't figure out what the numbers are, that those two angles are going to be congruent. So if you remember from our last video, as long as you know two angles of one triangle are congruent to two angles of another triangle, that's enough to prove that they're similar because we could figure out the third angle. So we know that for this problem, triangle, and here we go, this is where we can name it however we want. I'm going to call this one ADE. So triangle ADE is similar to triangle. So now I need to match them up. So A matches up with A, D matches up with B, and angle C would match up with angle E. So I know that triangle ADE is similar to triangle ABC. All right, here's another example. So in this example, we're going to use some other things that you learned from or in previous math classes last year in Math 8. All right, so give me a moment to sketch this out. I'll try to be better. Oh, I'm not starting off so well. Oh my gosh. Oh, wow. Actually, holy smokes, look at that. That's like almost amazing. Which means this. Oh, gee whiz. There you go. And then I ruin it. But, okay, it was looking good for a minute. Okay, I'm going to call this W, X, Y, Z. I guess I need to go backwards and do V. Okay. Let's say that I know that this angle right here matches up with that angle right there. And let's say that that's the only thing that I'm telling you. So hopefully you can see the two triangles in this picture. We have the large triangle right there, and then the smaller triangle right there. And what we're trying to do is to decide if these two triangles are similar or not. So what we're going to do is look at what information we know. The only thing that you're given is that those two triangles meet up. So what we know is that we can look and see if two of the triangles in this triangle are congruent to two of the triangles in this triangle, then we know that they would be congruent. Or, sorry, similar. If the angles are congruent, the triangles will be similar. The other thing we could do is look to see if the side measurements are proportional, but you don't have any side measurements, so we can't do that. So let's think about it. We got to know something else in this picture. Well, like I say, I wish I was Dora and you guys could answer me, but I'm going to remind you of the type of angle that's called vertical. Vertical angles are congruent. And that is something that you guys learn in Math 8. But vertical angles are congruent. So what that means is we must have some vertical angles in this picture somewhere. And we do. This angle right here is vertical to this angle. Because when angles are vertical, they share the same two lines or line segments and the same vertex, which is kind of where vertical came from. They have the same vertex and they're made of the same two segments. So we know that this angle, whatever it is going to be congruent to this angle right there. So now what that tells me is if those two angles are the same and those two angles are the same, then those two angles would have to be the same. Because if you think about it, if we had 180 degrees minus the angle with the one thing minus the angle with the two swipes, it's going to leave the open angle. So if we take 180 degrees and subtract this and subtract that, we're going to be left with that. And over here, if we took 180 degrees and subtracted the same small single with the same orange double, we are going to get the same, I think this is a dark purple, purple triple angle. So the answer to this would be that yes, these two triangles are similar. So now we have to make the call. So I guess we'll say VWX. So VWX is similar to triangle. So VWX means that this has to go YZX in order for the angles to match up correctly. All right, doing great. Okay, last one. Let's say that for example 5, so example 5 here. All right, so give me just a second to draw this one. Let's see, I'm going to do, all right, this is going to be awful, but like as always, we'll just pretend. Okay, oh yeah, this is getting worse by the minute here. Oh my gosh, okay, well, we'll just pretend, but, okay, so I'm going to call this A, B, C, and D, and hopefully you can see that there's a triangle right there, and then there is the triangle right there. So those are the two triangles that we are going to look at to see if we can match them up to be similar. Okay, let's say this one's 24, 30, and 36. And let's say this is, let's say 18, 20, and 24. All right, so here we go. So what I want to do is, we did this in the last example of the previous video. So this one is not so much a new versus original. So, but we can just say that this is like the first triangle here, and this is the second one. So I'm going to call this triangle 1 and this triangle 2. Okay, so I'm going to put all of these, the three sides of this triangle, in numerical order. So that would be 24, 30, 36. So 24, 30, and 36. So I'm just putting them in size, smallest to largest. So now I'm going to go over to this triangle and put these three in order, smallest to largest. So that would be 18, 20, and 24. So I just put those three in order, smallest to largest. So this way I can see that the side of this triangle that's 24 matches up to the side of that triangle that's 18. So later on when I need to get the letters, I'll be able to. All right, so now what we want to do is go through and reduce all of these guys. So let's see. If we start here, we can reduce both of those by 6, which would make this 4 over 3. Right here, we can cancel that out, which makes this 3 over 2. And then right here, we can reduce both of those by 12, which makes that 3 over 2. So if we look, these are not in proportion. Those two sides are, but those are not. So for this, we would say that the triangles are not similar. Are not similar. And again, the reason is that the side measurements are not done by the same scale factor. If this had been 3 over 2, then the answer would have been yes, they're similar, and the scale factor is 3 over 2. Okay, so that should get you started on similar figures and whether you can prove them to be similar, again, based on the angle measurements or the side measurements being in proportion.